Good morning, everyone. I hope you guys had a great weekend. Getting all your work done over the weekend. So I know there was some issues with Blackboard this weekend. So sorry about that. I don't really have any control over it, but I'm sorry that was happening. So anyway, we're going to be moving forward. I will be going through the midterm before the final. I did have a couple of people that really struggled with getting on Blackboard this weekend, so they weren't able to take the midterm, so we won't be going over it today. But we'll be moving on. We're going to be moving on to the next lecture. So we did complete lecture 6 on correlation and regression, looking at relationships, mostly used in descriptive research, and helping you to come up with questions that then could be tested with experimental research, and helping people to do predictions. So developing that line of best fit or those prediction equations using the slope and the intercept. So if you'll remember, we got through that. I decided not to include that on the midterm just because there were a few people that still hadn't done the homework just because they had problems with Excel, and I wanted time to be able to answer questions and go over that homework before I tested you on it. So I didn't include that on the midterm, as you saw. So that material from lecture 6 will be on the final, along with the material from lecture 7. The final will also have questions from the midterm. What I do is I pull out the most commonly missed questions on the midterm, and then I put them on the final. So you get another shot at trying those questions again. So the final in this class is comprehensive. I also want to let you know that I got our survey onto SurveyMonkey. So I will be sending you that link. I'll send you a link for you to look at the survey and then make suggestions if we need to add any items or if you like a different item better. I did try to make them even. So I did 5 questions for contraception, which included some questions about condom use. And then I did have 5 questions for the sexual permissiveness. And we'll be reverse scoring some of those, so we kind of have them all scored in the same direction. For instance, it's probably healthier for you physically as well as possibly emotionally and spiritually to be less permissive sexually, especially around the number of partners that you have, an individual has. So we'll be reverse scoring those items, since the items are stated like that it's good or okay to have many partners, that it's good to have casual sex, or it's acceptable. So we know that that's up to each individual, but that it does put them at more risk for STIs and for other possible negative outcomes. So we would reverse score those. So if somebody highly agreed with those and put a 5 that they highly agree, we would reverse score that and they would only get 1 point. Okay, so that's what we'll do for the statements that could possibly put the person at risk physically for STIs or for even possibly violence or that kind of thing. So I will be sending you that link, and I ask you to review it and then give me any feedback if you think it looks okay, if you think we need to add something. I kind of put a statement about the sexuality education, and then I would like feedback from you if you think that that's going to be able to measure that well, or if we need to add anything, we need to make it more complex, or what we need to do. So please look at that, and I'm hoping to get that back really hopefully by tomorrow afternoon, and then that way I can get it finalized and get you guys the link so you can get it out and we can start collecting our data. Okay, so that's what's going on with the project. So any questions before we get started? Yes, Rachel.
I have to leave at 11 for a meeting, but I have a really quick question on where I saw that you wanted us to turn in the midterm review document that you sent out, that's due at the end of the day today.
Wait, say again, Rachel. I'm not hearing very well.
I thought I saw on an announcement that the midterm review that you sent out is due at the end of the day today. Is that not a thing?
No, that's not a thing. That was just for
Okay.
you to have. But
Okay.
I am going to offer some extra credits. After everybody finishes taking the midterm, I'm going to offer you guys an extra credit where you go in and take all of the midterm scores, and then you do some descriptive statistics on it. So you're going to be doing descriptive statistics and then telling me what your Z-score is, like what's the average for the group, what's the standard deviation, what's the standard error, and then you would tell me what your Z-score was and what percentile you fell at in the class. So I'll be sending that out probably tomorrow, and that'll give you 2 additional extra credit points for the midterm if you complete that and send it to me.
Okay.
I'm going to actually put I'll make like a little quiz for that, so you can choose I'll actually probably ask you mean, median, mode, and range, standard deviation, standard error, and then I'll ask your Z-score with a text box, since they'll all be different, and then what your percentile was. So I'll have you guys do that if you want to get some extra credit on the midterm. Okay?
Okay, cool.
So that'll just be another demonstration of the material that was on the midterm. Okay, but no, that midterm review is really just for your benefit to go through and help you prepare. Okay, any other questions? Okay, great. So we're going to be going on to our next lecture, which is lecture 7, and we're now in module 3. So actually, if you bring up module 3, you'll see that we're going to be covering lecture 7 and 8. I'm actually not going to cover lecture 9, so we won't have lecture 9. We'll have lectures 7 and 8 this week. And we'll be talking more about probability, and we'll be talking about differences in lecture 7, where in lecture 6 we talked about relationships. What you need to make sure that you complete for this week, the discussion board is due tomorrow afternoon, so you could go on and do your discussion board as soon as possible, but it is due by the end of the day tomorrow. Quiz 6 and homework 6 are due by the end of the day today if you haven't already done them. And then homework 7 and quiz 7 are going to be due probably by the end of the day on Thursday, because we'll finish the lecture on Tuesday, so I'll give you a couple of days. And then you'll have your journal. Entry 3 will be due by I'll probably make that due by the end of the day on Thursday too. Okay. The other things you need to do this week is review the survey and get back to me tomorrow. So I'll be sending that in an email today, and then sending it out to your contacts to be able to, your contacts between the ages of 18 and 30, to be able to try to get some feedback, which would be good. Okay, so we're going to be jumping into lecture 7. So hopefully you have that outline available for you. I'm also going to share it on the screen. I only have one screen today because I'm in the office and I don't have another screen that will hook up to my laptop. So I'll have a harder time seeing your faces while we're doing this. Okay, so let me get back to you now that I have this up. Okay, so I'm going to screen share the lecture outline. Okay. Okay, are you guys seeing lecture 7? Yes? Okay, awesome. Okay, then I'm gonna try to get the chat up also. This is gonna be interesting to get all this done. Okay. Okay, so I've got everything. I've got some pictures going of you guys. I've got my chat up. Okay. So okay, great. So chapter or lecture 7 is going to be focusing on differences. Okay, so we're going to be talking about inferential tests that can look at differences. Okay, the beginning of this lecture does talk a little bit about probability. That's what statistics is all about, and I kind of has shared that with you in the past, that statistics are all about probability, mathematical probability. So it's all about the odds that an event will or will not occur, okay? So these odds never exceed 1, and they are never less than 0, okay? So they're between 0 and 1. And probability is defined by the ways a specific event can occur, okay? So it's the total number of ways associated equally with the likely events that can occur. So basically, like for instance, every time you throw a dice, it's going to be 1 out of 6 opportunities, right? Because there's 6 numbers on a regular dice. So if you throw a dice, you have a 1 out of 6 chance of getting one of those numbers, right? So if I say, what's the probability that you'll throw a 4? It would be 1 out of 6. Okay, 1 out of 6. You could also look at that as a decimal, right? So I could take 1 and divide it by 6, and it would be a 0.1666 chance, okay? Or about a 16.6% chance that I will roll a 4 on a 6-sided dice. Okay, does that make sense? Okay, so what would be the probability that I would roll an even number on a dice? Okay, so how many even numbers are there on the dice? 2, 4, 6, right? So it would be 3 out of 6. Okay, so I have a 3 out of 6 chance. I have to reduce that down, right, to 1/2. Right? So 3 goes into 6 2 times, so 1/2. So I have a 1 out of 2 chance to roll an even number, or 1 divided by 2 is 0.5, or 50% chance. I have a 50-50 chance that I'll roll an even number if I roll the dice. Okay, does that make sense to you guys? Okay, so that's what probability is all about. It's just that mathematical probability. So if I sat and I rolled the dice 1,000 times, about 16% of the time I would get a 4, okay? Because I have a 1 out of 6 chance. So if I roll it over and over and over and over and over again, eventually it would even out to be about 16%. Okay, unless I had a loaded dice, which hopefully we're not doing that. Okay, so, or if I said, how many times will I get an even number? If I rolled the dice 1,000 times, about half the time I'd get an even number and about half the time I'd get an odd number. Okay, so that's what probability is. It's mathematical probability. Okay, so now something could affect that. Okay, we could have some error. What if we did have some weighting on the dice? What if the dice was worn down on one side? What if there was, you know, I don't know, water on the desk I was rolling it on that affected the way the dice rolled? So there's always factors that can affect that probability. That's where error comes in. Okay, we always have some error. So it's important to remember that we're always going to have some error involved in the probability. Okay? But that's how statistics work. It's all about probability. But if we randomly select our sample and we have a large enough sample, okay, then we know in descriptive research, if we have 10% of a large population or 20% of a small population, that we can be pretty sure we're going to get fairly accurate results that can be generalized, okay? If we're doing experimental research and we have good internal validity, we've randomly selected our sample and we randomly assign them to the groups. And maybe we have, so we have that control group and maybe we have blinding. We know we have a really pretty good internal validity. We can be pretty sure about the outcome. Even though there's going to be some error in there, we can still be pretty sure about the outcome. And if we have at least 15 to 30 people in each one of our groups, each one of our experimental groups, and then our control group, we can feel fairly confident about our ability to generalize or have good external validity. Okay, so that's all based on the probability. Okay. So how do we apply probability to the scores? Okay, either to individual scores or to sample scores. So remember, all the way along since we've been talking about normal distribution, sometimes we're doing some comparisons with individual scores. So if we use an individual raw score, we're going to use the standard deviation in order to get our range of scores for our 95% confidence of those scores being part of that population or being outside of that population or being considered different, okay? Or if we want to look at sample means, right, we would have the mean of the means, and then we would use standard error to look at that range, that confidence interval, that confidence range, okay? Or if they're different. So now we're going to be applying that even more during this, lecture, okay? So when we apply that, the odds that a given score may occur can be directly calculated by the placement of that score in the normal distribution or in that Z distribution with the mean of 0 and the standard deviation of 1, okay? And then we can look at those comparative percentile scores. So the odds that a given sample score may occur can be directly calculated by placing that in the distribution with the standard error, okay? So the p-value associated with these tests of significance or with these inferential tests indicates the probability of the occurrence of that score, okay? So my p-value is the probability of the occurrence of that score. So the example might be that the p is equal to 0.001 means that this score will likely occur only one time in 1,000. Okay, so remember the first 0 is the tens, the second 0 is the hundreds, and the third 0, the third slot is the thousandths. So that's 1,000th. Okay, 0.001 is 1/1000th. So one time out of 1,000, or 0.1% of the time, this score would occur. So we know it's different. Okay, it's less than 0.05 or 5%. So 0.1% is absolutely less than 5%. Okay, so we know that yes, we can be pretty confident at a 95% level that that score would be different. It only occurs one time out of 1,000. Okay, which is pretty rare. Okay, so the basis for that test of significance. So what we're going to be doing is we're going to be having a comparison of the overlap between the two distributions. Okay, so if you'll remember when I did an overlap between one normal curve overlapping with the other normal curve to see if those scores were more than 2 standard deviations apart. That's basically what happens when we're calculating the probability level. Okay, so each sample could be overlapping to their distributions to see if one distribution falls within the normal range of the other distribution when we're doing that comparison. Okay, so if they fall within 2 standard deviations, then they are not different. If they fall outside of the 2 standard deviations, they are considered different. Okay, so we're looking at that normal range, that confidence interval. Okay, so I've kind of already shown that to you. I showed that to you last Thursday when we were talking about chapter 6, and we were talking about the p-value of the regression. Do you remember that when we talked about the p-value of the regression? If we could tell whether that correlation was statistically significant, we looked at the F calculation, the F value, and to see what the probability is that that would be falling within that normal distribution. Okay, so it's the same concept. It's the same concept. And when I do a example, I'm going to pull up a whiteboard here in a second. When I do an example, I'll show that to you. Okay. So, but let's go through a little bit of terminology again, just so we're all on the same page. You guys know what a hypothesis is. Basically a statement that the researcher thinks concerning the outcome of a research project. So it could be null. So it could say, I don't know where a difference might be, so I'm going to say there's no difference. Okay, so I could say there's no difference between these two groups. That would be a null hypothesis. Okay, there'll be no difference between these two groups. So if I randomly select a sample and then I randomly assign them to 2 groups, and then maybe I'm measuring, maybe my dependent variable is stress level. So I'm giving them a stress assessment to get a number. Those stress assessments actually collect the number of stressful occurrences, and different occurrences have different levels or weightings. Okay, so let's say I'm collecting their stress levels pre and post, and for one group, I'm going to have them meditate, and the other group, I'm not going to have them meditate. Okay, so the one group, let's say I'm going to have them meditate on relaxation, and the other group, they don't engage in meditation. And then I measure their stress pre, then we wait 8 weeks. The experimental group goes through the meditation curriculum or practice, and then the control group doesn't, and then I measure them at post. Okay, so my null hypothesis would state there will be no difference between the meditating group and the non-meditating group on their stress level. Okay, that would be a null hypothesis. Okay, but maybe I had looked at some research, which I should. If I'm going to do a study like that, I should look and see what's out in the literature and if anybody else has done research. And I find that there actually is a correlation. I've seen people do descriptive research, and there's a correlation between people who meditate or people who consciously engage in relaxation and lower stress levels. So I see that there's actually a direct relationship between meditation and relaxation and lower stress. So I say, well, gosh, there's that really strong correlation there or relationship. I wonder if it's causal. I wonder if engaging in meditation on relaxation lowers stress level. So I think maybe there is a cause. So I might do what's called a alternative hypothesis, okay? Alternative or directional hypothesis, and I might make a hypothesis that says meditation on relaxation will lower stress levels. Okay, that's also a hypothesis, but it's stating that I think the meditation and relaxation will lower stress levels. Okay, so that's called an alternative hypothesis or a directional hypothesis. Okay, so then what I'm going to do once I state my hypothesis, then I want to test that. I want to actually test that. So I collect the data. Then I need to generate some inferential statistics. So I need to run a statistical test, an inferential test that will produce a test statistic. So for regression, it was the F. We produced the F, remember the F statistic, and then we wanted to see if that was significant. Okay. So we can test for differences also using a test statistic. Okay. And we're going to generate a critical region, a probability region, okay, where the value must fall in order to reject the null hypothesis or say that there was a difference. So if I said there was no difference and then there actually is a difference, then I'm rejecting the null hypothesis, okay? If I say there is a difference and there is a difference, then I'm accepting the alternative or the directional hypothesis. So it doesn't really matter if you accept or reject. It depends on what your hypothesis is. So if I've stated a null hypothesis, there will be no difference, and then there is a difference, I will reject my null hypothesis. If I stated a directional or alternative hypothesis, I said, I think that stress is going to reduce I think that meditation is going to reduce stress, and then I actually see that there is a difference between the experimental and the control group, then I will accept my hypothesis. There was a difference. Okay, my experimental group did have a reduction in stress. Okay, so I'm going to develop that critical region. Now, the critical region and the significance level are connected, okay? So if my critical or my alpha region, where the unusual scores have to fall, I've already stated to you that in health science research, we usually use, or exercise science research or social science research, we usually use an alpha level of 0.05. So we've been talking about that, 5%. We usually use an alpha level of 0.05, which means that my significance level or my odds is 95%, okay, or those 2 standard deviations. So the critical region is 0.05. That means my significance level will be 95% or 0.95, okay? So if I decided that I wanted to be even more strict on my alpha level, so I wanted to be even more strict and I wanted to only be wrong 1% of the time, or I only wanted those odds to be 1%, then my alpha level would be 0.01 and my significance level would be the 99th percentage or 0.99. So I would want to go out to the third standard deviation. So there's some research that you might want to be more strict with your critical region and your significance level. Okay, and we'll talk more about that later. Okay, so the p-value is the probability that's associated with my test statistic. Okay, so a p-value of 0.01 means that there's 1 chance out of 100 or a 1% chance, okay, that the statistic falls within the normal distribution, okay, that I'm wrong, okay. If I'm at a 0.05, there's 5% chance. That would be falling outside the second standard deviation. If the p-value is 0.01, that means that the test statistic is falling outside the third standard deviation. Okay? Okay, so I've kind of talked about this, but I'm going to give an example. So here's an example. I can state a null hypothesis. A random sample of 30 women and a random sample of 30 men are measured to determine their average body weight. The null hypothesis is as followed. Okay, the average weight of women will be no different than the average weight of men. Okay, so I stated a null hypothesis. I said there'll be no difference. Okay, so now I'm going to choose a significance level. I'm going to say that I'm going to choose the 95% significance level and a 0.05 alpha level. Okay, a 0.05 alpha level or critical region. Okay, so now I'm going to choose what my test statistic is going to be. What inferential test am I going to use? Okay, I can compare my sample to my population. That would be a z-value. I can compare my sample to my sample. That would be a t-value. Or I can compare 2 or more samples, and that would be an f-value. Okay? So the critical region is based on my alpha level and whether I'm using a 1 or 2-tailed test. Okay, so I'll be explaining that here in a second. If I use a, that's all based on whether I do a null hypothesis or a directional hypothesis. Okay, so I would run my inferential test, and then I would determine based on the outcomes of my inferential test whether I'm going to reject the null hypothesis or accept the null hypothesis, whether I'm going to say there is a difference or indeed, yeah, there was no difference. Okay, then I will state my conclusions. Okay, so that's basically how the research will go when I'm using differences, when I'm doing experimental research. Okay, so the 2-tailed test means that the critical region is divided by positive and negative side of the distribution. Okay, so let me show you that on, let me now kind of go through that on the whiteboard so you guys will be a lot more clear on that. So, okay, so can you guys see the whiteboard now? Yeah, can you see the whiteboard? Give me a thumbs up. Okay, okay, so if I do, I'm kind of moving my stuff around. Okay, so if I have my normal curve, okay, okay, so if you'll remember, this was 68%, this was 95%, and this was 99% of the scores, okay? So what that does is it gives me the 0.05 significance level, okay, or the the 0.01. So the 0.05 is going to be between, here we have our z value, the average of 0 and the standard deviation of 3, I'm sorry, of 1. So 1, 2, 3, -1, -2, -3. Okay, so we've got our z-scale. So we know that if we are at the 95th percentile, that's 2 standard deviations. So 95% of the scores fall within those 2 standard deviations. And you can even add that up. So we know that 34% of the scores fall in this standard deviation, 34% here. So that's 68. Then we know that 13.5 and 13.5 fall in the next 2. So if I add those, that's 27. So if I add 27 and 68, that actually equals 95. So if we add these percentages up, so that goes back to, that connects in with the percentiles, if you'll remember. So if we add all that up, that's 95%. Okay, and then this next area is about 2.4, 2.4. So if we add about 4% more, 4.8% more, we're at 99 or 99.8. Like almost all of our scores fall at the 3rd standard deviation. Okay, so you guys need to remember that. Okay, you need to remember that. So this is the 99th. Okay, are you guys with me on that? Okay, I need to know that you really remember that, so that you would, that's just burned in your memory. You should be able to just draw that out and know, okay, what those percentages are. Okay, so what happens then is if we're testing sample scores or even raw scores, we know that if a score falls outside of the 2nd standard deviation, because we're going to be using the 0.05 significance level, okay, or the 95th percent confidence level, okay, so if we know that scores fall outside that, so if they fall anywhere in this area on both sides, that's about 5%, okay, 2.4, and this is 0.1. Okay, or it's actually less, but just I'm going to use that for example. So, so we have 2.5% on one side, and we have 2.5% on the other side. So 2.5% on the positive side, and 2.5% on the negative side. So if we did a null hypothesis, we'd be doing a 2-tailed test. We'll be looking for any differences on the negative as well as the positive, because we don't know where the difference comes from in a 2-tailed test. It could be on one side or the other, okay? So that's a 2-tailed test. That's what you use with the null hypothesis. So if you're using a null hypothesis and saying, I don't really know where the difference is, that's a 2-tailed test, okay? But if you think you know where the difference is from other correlational research or other research that's been done, so if I think, you know what, I do think that if you do relaxation meditation, you'll have lower stress levels, okay? Then I'm gonna be looking only over here at the negative side, because I'm only looking for a reduction, okay? So I'm looking for lower stress levels, okay? So I would only be looking on this side. I'm not looking on this side at all, because I don't think the scores are gonna be higher. I think the scores are gonna be lower in my experimental group. So I'm going to put my whole 5% on this side. So I know that this is the 2.5%. And so actually what happens is the computer will draw that back just a slight bit to get 5% more. Okay, and it looks for all the difference only on this side. So your whole 5% is on the negative side if I'm saying it's going to be less. That the stress scores will be less in my experimental group than they are in my control group. That's called a 1-tailed test. It looks for all the difference only on one side. So that's a 1-tailed test. Okay, so if you use a directional hypothesis, that's a one-tailed test. If you use a null hypothesis saying, I don't know where the difference is, that's a two-tailed test. You're looking for the difference either to the positive or to the negative. Okay? Questions about that? Anybody? Okay. Okay. So that's making sense to you guys? I hope so. Okay, so let's go and let's go back and let me get off the screen share, maybe. Okay. And I'm going to go back and share the lecture again. Okay. Hang on, I'm going to get my chat up just in case somebody's asking me. Okay, so I'm going to move on. Okay, so if I go back to this example I was using here, I think I was males and females randomly assigned, or no, what did we do? 30 women, 30 randomly selected women, 30 randomly selected men, and we were going to say their weights won't be any different. Okay, then we're going to apply. We have two measures, so we're going to actually apply. If we go back to this, so here's our example, and we're going to state a null hypothesis. We're going to say there'll be no difference between their weights. We're going to do a sample to sample. Under number 3, we're doing sample to sample. So we're going to be calculating a t-value, okay? Not to be confused with a t-score, okay? Like the z-score and the t-score. Okay, this is different. This is a t-value, okay? So we're going to calculate a t-value, okay? We're going to use the 0.05 critical region. So we're going to have a 95% confidence, and you want to state that up front before you do any analysis. You don't change later. Like if you end up having a really, 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 really low probability, like 0.00000015, then you don't all of a sudden go, oh, well, now I'm going to change to the 0.01 critical region, alpha region. No, you state that what's called a priori. You state that before you do the analysis. That's just integrity. Okay, you state that ahead of time, and then you run your analysis, and then you state your results. Okay, so then we're going to look for our t-value, okay, to see if there's a significant difference. Okay, so we're going to be looking at a two-tailed test because we stated a null hypothesis. Okay, so once we get the results, okay, I know that when I find my t-value, I can compare it against a critical t. Okay, so there'd be a t on, say, like a, in your book, you can look in your book and there'll be a chart of t critical values that you would compare your calculated t with your t critical. Okay, so if my calculated t is larger than my t critical, then I know that there's a difference. Okay, so if my measured t exceeds my critical t, if it's larger, then I know that there's a difference between the two values, the two means. And the probability is also going to show that. So the probability will be less than 0.05, and the t-value will exceed the critical value. So you can look at both of those or either one of them. So if your calculated value exceeds your critical value and your p, your probability is less than 0.05, then you know there's a difference. Okay? There's a difference between those two scores. You can be confident, 95% confident that there's a difference. Okay? So if your calculated t exceeds your critical t, your p-value is less than 0.05, then you know there's a difference. So in the null hypothesis, you said there was no difference. So then you would reject the null hypothesis. You would say, I reject the null hypothesis. There is a difference between the weight of women and the weight of men. There's a statistically significant difference. And then this is how it actually, what it actually looks like under number 6. We would write, we found the mean weight of men is statistically significantly heavier than the mean weight of women. The calculated t was 2.7. The p-value was less than 0.01. Okay, so that's how it would be written up, say, in an article or in your lab report. Okay, questions about that? Anybody? Let me see your beautiful face. I can't see some of you guys. Anybody have questions? Okay, and I'll keep moving on. Let me kind of see where I'm at, because I'm going to take 2 days for this. Probably want to get down to ANOVA. So I'm going to talk about doing t-tests. Okay, but before that, actually, I think I'm going to talk about type 1 and type 2 error tomorrow. I want to talk about t-tests because, like in that example, we would have done a t-test. We would have had males and females. We would have 2 groups. So we're going to do what's called a t-test. Okay, so t-tests use 2 groups. Okay, 2 groups or 2 scores. Okay, so if I have that, example I just gave you, the males and the females, okay, I have 2 separate groups and I have 1 measure, the weight. So I have males and females and I have 1 measure, the weight. That is called an independent sample t-test. That is a between measure. Remember between and within? The independent t-test is a between measure. It's between 2 separate groups, males and females. Okay? So you will determine, I'm going to do a t-test. When you have 2 groups and you want to see if there's a difference between them, you would do a t-test. Okay? You would determine the critical value. Okay, so are you doing alpha level of 0.05, 0.01? You would determine whether you're going to do a 1-tailed or a 2-tailed test. So we said there was no difference. There's a null hypothesis. So are we doing a 1-tailed or a 2-tailed? So hold up, 1 or 2. If we say there's no difference, null hypothesis, we don't know where the difference would be. Would that be a 1-tailed or, sorry, I lost you guys. 1-tailed or 2-tailed? 1 or 2? Just guess, you guys. Jordan, I see you saying 2. Nicole, 2. Okay, you guys are right. 2-tailed because we don't know where the difference is. So remember, okay, I see on the chat, 2-tailed. Okay, so yes, we're on a 2-tailed test because we said there's no difference. Okay, so let me go back to the lecture. Okay, so we've got a two-tailed test. Okay, then we're going to actually do the analysis. We're doing an inferential test called a t-test, and we're going to see if there's a difference between those two groups. Okay, and then we'll be looking at the probability value. Okay, so we'll look at the calculated t-value, compare it against the critical t-value, and then we'll look at the probability level to see if there's a difference, okay, for a two-tailed test. Okay, so that's a independent between groups sample, okay? The other kind of t-test you can do is a dependent sample t-test. So the other example that I was using where I was saying, hey, if we do meditation, will that lower stress levels? Let's say we just had one group. We were not doing experimental research. We just had one group and we wanted to see if people do meditation, does their stress level reduce? Okay, so all we're looking at is the stress level pre to the stress level post. The stress level pre to the stress level post, okay? So I have one group, but I have two measures of a score, pre and post. One group that I'm doing meditation with, I measure their stress level pre, I measure it post, pre and then post, and then I'm going to see if there's a difference. So I have one group with two measures. That's called a dependent t-test or a within measure. Within the group, was there a change? Within one group, pre to post, did I see a change? That's a dependent t-test. So independent, two groups with one measure. Dependent, one group with two measures. So write that down because you got to know it. Okay? Write it down because you got to know how that works. Okay? One group with two measures is the dependent. Two groups with one measure is the independent or the between. Okay? And then the dependent is the within. So write that down. You just got to know that. Okay? Because you got to know what test to use. So when you go into Excel, it's going to ask you, do you want a match or a paired or a dependent sample? Or do you want an independent sample t-test? You'll have to know which one to choose. Okay, so if you only have one group with two measures, then you're going to go like, oh, okay, that's a dependent or a within. But if you have two separate groups with only one measure, okay, then you're going to go, oh, that's an independent or a between. Okay? Okay, so maybe let's look at that now. Maybe let's look at that. Okay, so I'm thinking maybe what we do is pull up the homework. What do you guys think? We'll pull up the homework because in the practice homework, you have to actually run some t-tests. Okay, you're going to run an ANOVA too, but we're going to talk about ANOVA and error tomorrow. And so I'll do that example tomorrow. So while I get practice homework 2 up, why don't you guys take a stretch or a breather? Stand up, stretch, take a breath so I can, while I go in and get this up. Okay. Okay, so I have the, I've got the practice homework 7 up. Okay, so in practice homework 7, you're going to be, you're given some data. Hang on, I'm getting my chat back up. Keeps disappearing. Okay, in practice homework 7, you're given some data. So I gave you some data. This is actually data from a research study that Dr. Dallum and I did a few years ago. So we measured mean arterial pressure pre and post on a single group of participants from a research study we did at a work site. So we were at a local work site in Pueblo, and we were engaging some health promotion activities to see if we could lower diabetes and heart disease risk in a work site setting. So that was the research study. So one of the things we looked at was mean arterial pressure. And we looked from January to August in our entire group. Okay, so we've got this whole entire group of participants. Okay, we gave you, okay, so if we look over here, you can see that we had divided them up into 3 groups: the group, the one-on-one, and the passive. Okay, and so what happened is that the group people, they got group education. Okay, they got education as a group. Okay, the one-on-one people, as it states, they got their education one-on-one, and then the passive people, they just got some passive education. They just got like some, they just were exposed to like some posters and some kind of passive things that were in the hallway, some kind of media stuff, things they got in email, but it was no formal education. Okay, so then what we did was we collected a bunch of data. We looked at their resting heart rate. We looked at blood pressure and calculated mean arterial pressure. We looked at their glucose, their fasting glucose levels. We checked their cholesterol. Like we looked at their weight, BMI. We looked at a bunch of stuff. Okay. We did waist to hip ratio. So we collected a whole ton of data. Okay. So this is just one little bit of the data that I'm giving you, is the mean arterial pressure. Okay. January. And then that was our was in January. They did the education for 6 months. And then we recollected the data in August. Okay. So you've got some data here. Okay. So now the homework is asking you, let me go look and see what the homework is asking you. Okay, so the homework is asking you, what is the mean arterial blood pressure before and after? Okay, so it's just asking you to get a pre and post for everybody. And then it's asking, did the program reduce the blood pressure significantly in everyone overall? Okay, then it asks you to divide it men versus women. Okay, so it's saying, was there a difference in mean arterial pressure of men versus women at the beginning of the program? And then it's asking you, did any of the 3 groups change their blood pressure from before to after? Okay, so when we're asking, did the program reduce the blood pressure significantly in everyone overall from pre to post? So we're looking at one group, the whole group, one group, and we're looking pre to post. So it's one group with two measures. Okay, so using your chat function, would you use a dependent or an independent test? Okay, one group, two measures. Would you use an independent t-test or a dependent? Okay, very good. You would use a dependent t-test because it's one group with two measures. It's a within measure. One is dependent on the other. It's one group, okay? So we're gonna do a dependent t-test there. Then it asks you to divide the group up by men and women and just look at their pre. So now we have men and women, and we're looking at, is there a difference at the beginning between men and women on their blood pressure? So two groups, one measure. So is that dependent or independent? Two separate groups, one measure.
Independent?
Really good. That's independent. Okay, that's a between measure. Okay, two separate groups, one measure, the pre-blood pressure. Okay, now if we divide them into the three groups, passive, one-on-one, and group, so the three different kinds, and then for each one of those, so we go into passive and we look at them pre to post. What is that? What kind of measure is that? We just look at the passive pre to post. Is that a dependent or independent? Very good. That's dependent. That's within that one group. We're going to look at the passives pre to post. Then we're going to look at the group pre to post. Then we're going to look at the one-on-ones pre to post. Those are all dependent measures. Okay? So if we go back to the Excel spreadsheet, are you guys still seeing the Excel? What are you seeing right now? The Excel? Okay. So if I go back to the Excel spreadsheet, I had gone to the homework. Okay. Are you seeing it? Wait, I got to make sure I'm on the one you're seeing. Okay, I think this is the one. Yeah, this is the one you're seeing. Okay, so, oh, dang it. So if I go back to this, what I'm going to do, the first thing it asked me to do is just find, sorry, I don't know what's happening to my internet. It's just going in and out. Okay, so let me go back to the share, get us back on that. Okay, so if I go, the first thing it asked me to do was find the mean of the whole group pre and post. So what I did was I just ran some descriptive statistics. You can see them over here to the right. Do you guys see them? The map January to the map August. Okay, so I just ran some descriptive statistics on the pre and the post on the whole group. Okay, so I did the pre's, and remember to run the descriptive statistics. I'm just going to go to the oh my gosh, I've got too much stuff up on my screen. Sorry. Let me move some of this stuff. Okay, I'm just going to go to my formula and just do an average on that whole line of data. This whole line of data in D is the pre's, the whole line of data in E is the posts. So I'm just going to run some descriptive statistics on that, and I see that my mean blood pressure pre was 99, post was 100, okay? And then I can see all the other things, the standard error, the standard deviation, okay? And I had 69 measures. Okay, so I had 69 people. So I want to see if there's a difference overall. So overall in the whole group, was there any difference pre to post? Okay, so I think, yeah, so question number 2, I did pre to post for the whole group. Okay, so what I would do to do that is I would go to data, I would hit my data analysis, and I would go to t-test. Okay, so now when you go down to t-test, you're going to see several different kinds of t-tests. Okay, so the t-test paired, and you need to just make note of this, the t-test paired, that is the dependent or the within t-test. The t-test paired is the dependent or the within t-test. Okay, the t-test to sample, and when it says assuming equal variances, that means that you have about an equal number, a fairly equal number of participants in each group. Okay, so you're going to be using the t-test paired, the t-test to sample assuming equal variances for your independent t-test. So for the independent t-test, for this homework, you would use the t-test to sample, that's the between, assuming equal variances, okay? The to sample assuming unequal variances, that is if you have, like, if you're looking at one sample that has, say, 10 people in it and another sample that has 200 people in it. You would use that. You would use the unequal variances, okay, when there's a huge difference between your sample sizes. And then the last one is the z-test, and that's where you would be looking at a sample against a population. Okay? Okay, so what you're gonna mainly use in this class is the t-test paired for your dependent or within, and the t-test to sample equal variances for your independent or between. Okay, so this very first measure that we were gonna do, we were gonna look at the whole entire group, one group, pre to post. So we're gonna be doing the paired t-test because it's a dependent measure. It's paired, it's one group, pre to post. So I'm gonna say okay. Now it's gonna ask me for variable 1 range. So my variable 1 was the pre. I'm gonna grab all of that data, okay? So I'm gonna grab all of the data in my pre-group, and I can, again, I can grab the labels. So, oops. I'm gonna grab all of that all the way down to the end. Okay, and then for my variable 2, I'm gonna do the same thing. I'm gonna grab my post. Ah, come on. I'm gonna grab my post data. Ah, I also forgot my mouse, so I'm using the dang little pad. Okay, and then I've got my labels, and then I'm gonna tell it where to put it, and then I would hit okay. Okay, I can also put the hypothesis mean difference. I can put 0.05 in there if I wanted. You don't have to, but you can put it in there and it will tell you. But it's gonna tell you your probability level one way or the other, okay? So then I would tell it where to put this and I would hit okay. Okay, so if I don't tell it where to put it, it'll just put it in a new workbook, okay? Okay, so this is what the output looks like. right here, question 2. So this is what a t-test, a paired t-test would look like. It still shows you your means. So that's the same as we already got because nothing changed. Okay, 99.46 for, or 0.47 for my pre, 100.23 for my post. It shows me all of that. But then what I do is I go down, and now my calculated t-value, my calculated t-statistic is a negative 0.75752. Okay, a negative 75.752 is my calculated t. Now, this was a two-tailed test. Oh, let's say we did a two-tailed test. Let's say we said there'll be no difference at from pre to post. Okay, there'll be no difference from pre to post in the whole group. Let's say we do a null hypothesis. Then we would look at the two-tailed test. Okay, so you can come down and you could look at the two-tailed test. Okay, so my two-tailed test, it shows that my critical value is 1.99. So is 0.75 larger than 1.99? No. So that tells me that there's no difference, okay? You can also look at the probability. Is 0.45 smaller than 0.05? No. So remember, we can look at this as a percentage. Is 45% smaller than 5%? No. So based on both of those measures, and they're always going to be the same, like they're always going to be the same. So if one of them you say, like if I were to say, oh, the t-stat was larger than the critical, but then I'm saying the probability is less than 0.05, that will never happen. They always are the same, okay? So if my t-value is greater than my critical value, then I know there's a difference. If my t-value is less, 0.75 is less than 1.99, okay, then I know there's no difference. And then that's confirmed with the probability. The probability is 45%, and I need it to be less than 5%, or it's 0.45 and I need it to be less than 0.05. Okay, so I know there's no difference in mean pressure from pre to post. Even though this is slightly higher, this was 99.5 and this was 100.2, this is slightly higher, but there's no statistical difference from pre to post. Okay, because that's confirmed right here. The t-stat was smaller than the t-critical, and the probability value was larger than 0.05. So there is no statistical difference from pre to post in the whole group. Okay, so any questions about that? Questions about that? Okay, so make sure you write down the rule to read this data outcome of this inferential test. This is an inferential test. It's just all about probabilities, okay? So it looked at this whole array of data. The way you read this is you go down, you've decided whether you're going to use a one-tailed or a two-tailed test. You know, let's say we would have said, we think men will have a higher we think, we're not there yet. We think there will be a difference from pre to post. We think there'll be lower blood pressure post. Okay, then we'd be looking at a one-tailed test because we're looking only at that there was lower blood pressure. Okay, so we would go to the one-tailed test and we'd see the t statistic, it's still 0.7575. Okay, it just happens to be negative because this was larger, right? Because it takes this minus this, okay? So don't worry about whether it's negative or positive. We're just looking at the difference, okay? I mean, I could have put this data here and this data here, and then it would have came out positive. So it doesn't matter whether this is positive or negative. So the t-stat is 0.7575, okay? So I'm gonna look at, is it larger than the calculated? So I would go down, I mean, than the critical. I would go down to my one-tailed critical, 1.66. So is 0.75 larger than 1.66? No. Is my probability value less than 0.05? 0.22 is not less than 0.05. 22% is not less than 5%. So even at a one-tailed level, it's still not different. There's no difference between the whole group pre to post. Okay? You got to know that. You got to know how to look at these outcomes and tell whether there's a significant difference or not. So if you're still struggling with that, go back and re-listen to the lecture. Go back and listen and watch the videos that I posted for module 3. Go back and read the book, or ask me, and we can chat. Whatever, okay? Because you've got to know how to do that, okay? So the next question, question 3, was it asked me to look at males versus females. It asked me look at women versus men at the pre-measurement. Women versus men at the pre-measurement. So I would have to go into my data and I would have to sort it by the gender. Okay, I would have to sort it by the gender. So I could go in and I could, if I can get my, I have to go in and I have to, this is almost impossible for me to do without a mouse. Okay, if I have to go in and I have to actually, I'm going to grab the whole data set, right? I'm going to grab the whole data set and then I'm going to go to home and I'm going to sort and filter, but I've got to grab, it wants me to grab this whole data set. Okay, let me see if I can grab it. Okay. Okay, I'm going to grab the whole data set. Okay, and then I'm going to go to sort and filter. I'm going to do a custom sort, and I'm going to sort by gender. I'm going to tell it okay. Okay, so now it's sorted me by gender. Okay, sorted my group by gender. The females first, and then the males. Okay, and I'm just looking at question number 2. I want to see, is there a difference between men and women at pre? Is there a difference between men and women at pre? Okay, so this is the men and women at pre, question number 3. Okay, so I would go in and I would do the same kind of test. I'm going to go to data. I'm going to go to data analysis. Okay, I'm still going to do a t-test, but this time I'm looking at 2 groups, 2 separate groups, 1 measure. Okay, men or women versus men at pre. Okay, so I have 2 separate groups, 1 measure. So I'm going to be using the t-test 2 samples. Okay, and I have similar number. It's not like I have 10 and 200, okay? So I have a similar number, so I'm still gonna use equal variances. It's not the exact same number, but as long as there's not a huge difference, you're gonna use the equal variances, okay? So I'm gonna say okay, and then my variable 1 range is gonna be my females, okay? So I'm gonna go to my pre-data, right? I'm going to, I'm sorry. I'm just going to grab my I need to get out of this. To get off of this since I had it selected. Okay, so I'm going to go in and I'm going to do the t-test, assume equal variances, and then my pre-data is just going to be my female come on, is just going to be my female pre-data. Okay, grab my female pre-data. Then I'm going to, for my post data, for the second range, I'm going to grab my male data at pre, because remember, we're just looking at pre. Just pre between males and females. Okay, so I'm going to grab my male data. Okay, I didn't have any labels in this. I just grabbed the data. I'm going to tell it where to put it, and then I would hit OK. Okay, I've already run these, so here's the outcome. This is what it would look like. This is my question number 3, I think. Okay, so the mean for women at pre was 98.78, and the mean for men at pre was 102.01. Okay, so it is slightly higher. The men are slightly higher. If I said, this is a null hypothesis, I don't think there's any difference between men and women, I would go to the two-tail test. So I know my t statistic was 1.31. My calculated t, right here, my calculated t was 1.31. On the two-tail test, my critical t was 1.99. So 1.31 is not larger than 1.99. So I know there's no difference. I can also look at my probability level on the two-tail test. It was 0.19 or 19%. That's not smaller than 0.05 or 5%. So I know there's no difference. There's no difference between men and women at pre. Even if I went to the one-tail test, I have the same outcomes. 1.31 is not larger than 1.66. The probability level was 0.09 or 9%. That's not smaller than 0.05. There's no difference. There's no difference at pre between men and women. Oh, I'm sorry, I was looking at the after, but there wasn't any difference at pre either. Again, so the next one was looking at post between men and women. So at pre between men and women, here it is right here, before the pre between men and women, there still was no significance. If you look at the probability value of 0.28 and this probability value of 0.14, there still was no significant difference at pre. And then if we go down after, if we go to the two-tailed, the calculated t was 1.31, the critical t was 1.99, the p-value was 0.19. That's not smaller than 0.05. So we're not seeing any difference. We're not seeing any difference. So we didn't see any difference at pre between men and women. We also didn't see any difference at post between men and women. Okay? And then the last question was to look at the 3 different groups and look at them from pre to post and see if there's a difference from pre to post. So we'd have to come back to our data and we'd have to sort this by the type of group, right? So we would go in, we would select our whole data, and then we would, We would select the whole data, grabbing everything. We would go to home. We would go to sort. We would custom sort it by group participation level. Okay, so it's going to resort it. Okay, now we're looking at the differences for each different group participation level pre to post. So one group pre to post. So we're going to use a dependent t-test, okay? So I could go in for the first one on question 4. I'm going to look at the group pre to post. Then I'm going to look at the one-on-one pre to post. Then I'm going to look at the passive pre to post. Okay, so I could go in and I could go to my data and I could go to my data pack. Maybe. Okay, so I've got one group pre to post. So I'm going to go back to my paired. This is one group, 2 measures, a within measure. And I'm going to say, okay, I want a within measure. My first variable range is going to be my group pre. So I'm going to grab the pre data for my, my pre data. Okay. I'm just going to type it in. My pre data is D4 to D19. Okay, and my post data is E4 to E19. Okay, so you guys see that? I wanted to look at pre to post just in this first group, which is unfortunately titled group. And then I'm going to say, okay, I'm going to tell it where to put it, and I'm going to say, okay. So this is what it would look like. My group data, it's a t-test paired because it was one group, 2 measures pre to post. Okay? So let's say I did a null hypothesis. I don't think there's going to be any change from pre to post on the group, the people that were educated in a group setting. Okay? So I would go to my 2-tailed test because I'm saying a null hypothesis. I find that my t statistic is 0.499. My calculated t is 2.14. So my t calculated is not bigger than my t critical. So this was the t calculated, 0.499. The t critical was 2.14. The t calculated, the t statistic is not bigger than the critical t. So there's no difference. I can also look at my probability, 0.62 or 62%. That's way bigger than 5%. So I know there's no difference from pre to post on the people that were educated in a group. Okay, no difference between pre to post. So I would accept my null hypothesis. My null hypothesis said there will be no difference between the pre and post test scores among the group, the people educated in a group. Okay? I would do the same thing on the one-on-ones. I would go to the data analysis. I would hit paired because I'm still one group, 2 measures. I would grab the data pre for the one-on-ones and post for the one-on-ones. And then this is what it's going to look like. Okay, for the people educated one-on-one, Their pre-measure was 106. Their post-measure was 102. I'm going to say that there's no difference. So I come down to my two-tailed test. I see that my calculated T was 1.45. My critical T was 2.31. Still not larger. I look at my probability value, I'm at 16%, still not smaller than 5%. So there was no difference in blood pressure pre to post among my sample that was educated one-on-one. And then I do the same thing on the passive people, and I find the same thing. There was no difference. Okay, now here's a good example. If we go to our passive people, let's say we were going to say, yes, we think our passive people would have a lower blood pressure. Okay, so we look at the T statistic, 1.68. The critical value is 1.69. Is 1.68 larger than 1.69? No, it's pretty darn close. And actually, this would say there would have been a significantly higher. Okay, it's seeing that at pre it was 97, at post it was 99. So it got really close to being significantly higher. The post got really close to being significantly higher, but it's 0.0509. So is that smaller than 0.05? Is 0.0509 smaller than 0.050000? No, it's not. It's bigger. It's got the 09. Okay, so even though this is super close, even this, if it's 0.04999999, yeah, that's still smaller than 0.05. But if it's 0.0512, that's larger than 0.05. Okay, so, if the T calculated is 1.689, that's still smaller than 1.6909. Okay, so it has to be, the calculated T has to be larger than the critical T, and the p-value has to be smaller than 0.05 for there to be a significant difference. So there's still no difference. There's still no difference from pre to post. No significant difference. Okay, even if it gets close. Okay, any questions? Any questions on that? Anyone? Okay, so that's how you run a t-test. Okay, a t-test for one group, two measures is a between, a dependent t-test. A t-test between two groups, one measure, is a between and an independent t-test. Okay? They both are measuring differences. Jordan.
So the whole time that we're looking at the one tail versus two tail, it all depends on what hypothesis we have?
Yes. So you're stating your hypothesis up front, right? So if up front you had a null hypothesis, you didn't know where the difference was, you always look at the two-tailed results. If up front you said, well, I think I know where the difference is based on past research, then you would always use the one-tailed. So that's based on your hypothesis, whether it's null or whether it's an alternative directional hypothesis. Other questions? Okay, so I don't think you have anything well, you do have something due today. If you have not done quiz 6 or lecture 6, you've got to get that done today. Okay. Nicole and Jordan, you guys have until I know you guys had issues. You have until the end of the day to get your midterm done. Okay. So get on there and get that done right now, because without that, it's going to massively negatively impact your grade, because it's 20% of your grade. Okay. And then Nicole, I know you had trouble with your Excel. So I've opened homework 5 and quiz 5 for you until the end of the day.
Okay, I already did the homework, and then I haven't checked until, like, I checked before class started for the quiz, but that wasn't open yet.
Okay, so I'll go recheck it right now. So that'll be open. So make sure you get all those things done by the end of the day. For the rest of you, you need to have homework 6, well, and all of you need to have homework 6 and quiz 6 done by the end of the day on correlation and regression, on relationship similarities, okay? And then by tomorrow, you've got to do your discussion. So you might want to get it done today if you have the inclination, okay? Any other questions? Okay, great. I will see you guys tomorrow then. Tomorrow we're going to be finishing up lecture 7. So we just did the t-test today. Tomorrow we're going to talk about ANOVAs, and that's more than 2 groups. But we'll still be talking about differences, probabilities, and then we're going to talk about type 1 and type 2 error. So if you haven't already looked at the videos for lecture 3, I would maybe be doing that too, because I think it could help you a lot. I mean, module 3. If you look at those videos on module 3, I think it would help you a lot. Okay, so, and then, you know, if you missed any of this lecture, you can go back and check it out too, because it'll be, I'll have it posted this afternoon. Okay, so if there's no other questions, I'll stay on in case anybody has any questions, but I look forward to seeing you tomorrow to finish up this, this lecture, and I'll look forward to seeing your scores, all the scores on the midterm, homework 5, quiz 5, homework 6, quiz 6, all completed by the end of the day today, and then the discussion tomorrow. See you tomorrow.
Dr. Faust.
Yes.
So on Wednesday, I'm gonna probably have to come to class a little late. My son has a doctor's appointment, and I don't know how long it's gonna run, but I just wanted to let you know.
Okay, sounds good. So on Wednesday, I probably am going to be doing some a little bit of review, and then talking about the lab report, how to do the lab report. So I'll be covering lecture 8, which is on the lab report. So you know, you can watch the whatever you miss on the recording.
Okay.
Okay, thanks for letting me know.
You're welcome. Thank you.
Sure. Catherine or Adriana, are you guys there? Okay, I'm gonna end video for EXHP 343 on Monday, July 20th. Thanks for watching.